friends, I am Dr. Chandra Jagan Mohan, and we have been discussing about various power generations we can have. And today we'll go for what is the physics of sun. What is the physics of the sun? And we'll know what is actually sun is and how it is able to do so much of generation of power, generation of energy. We will discuss in your coming slides. The solar energy. So the solar energy is the latest popular energy which is in the rising now. So we have been investing our efforts in the solar energy recently, in the recent decade. Before that, you cannot find a solar panel anywhere, but now you can find the solar panel even in the villages also. So that much is the popularity, that much rapidly the utilization of solar power has increased to that much of extent. So it is having a very good advantage of portability. So where you can generate from megawatts to microwatts, picowatts. Even for a small laptop, you can use a solar panel independently. And for charging also you can use independently. So okay, that is the thing. If you come to the solar domain of generating the power, so you cannot find this type of new technology. So where the photon energy is converted into the electrical energy, and the light, the heat energy, the sunlight energy is converted into thermal energy again. So this is the popular method where we are generating without turbine, mechanical movements in the case of photovoltaic. But if you go to thermal, that is a different case. So that's why it is called as the clean and quiet source of energy, because there is no mechanical part involved here in the photovoltaic, not in the solar thermal. So this is called as the quiet, clean and quiet method of producing the energy, power. So for producing the photovoltaic energy, we are using the photovoltaic cells, and for producing the thermal energy, we are using the concentrated solar panels. So these are the two different things in the solar energy: solar photovoltaic energy and solar thermal energy. These are two different domains. So since today our topic is about the physics of the sun. So actually, before going to this physics of the sun, so if you are talking about the sun, we have to talk about the birth of the sun. If you are talking about the birth of the sun, you have to talk about the birth of the Milky Way. If you are talking about the birth of the Milky Way, you have to talk about the birth of the universe. See, this is the point, the birth of the universe, the functioning of the universe. This is the point where the human brain, the intelligence of the human brain is unable to find. And for finding this answer only, the God has emerged. In finding the process of birth of this universe, whatever it may be, the Milky Way or stars or sun, the concept of God has entered. So the concept of religions has entered, and the concept of beliefs has entered. There is no much difference in the belief. The science has proven so many things without any belief. Yes, now we are in the age of no need to believe anything, so we can find it. Till now we have believed because we don't have that much of scientific knowledge, scientific equipment to find whether it is right or wrong in almost all the things. But regarding the birth of the universe, regarding the size of universe, and regarding the atom. So atom is the basic thing and universe is the large thing of this creation, whatever it may be, of this existence. Till now, scientifically, we don't know what is totally there in the atom and what is totally there in the universe. So what you are able to see, you are able to, whatever you have found up to now, without seeing, without finding any equipment like dark energy, also only comes on a 20% knowing about this universe. Remaining 80% we don't know about the universe. So here also, the science also is based on the belief theory, just like religions. So science also don't know what is the foundation, what is the roof. But in the middle things it knows with clarity, with proving the theorems. But without knowing the foundation, without knowing the roof, it is in between this. So bottom is the assumption and roof is the assumption. Okay. If you leave that different theories about gods. So whoever the theories have proposed the theories, they are human beings and they have proposed the human-centered theories only. So because we are calling it God, because we are thinking he might be like us only. Maybe he might be like a dog. We don't know. So in this, like that, similarly here also so many theories. The most popular theory accepted, we cannot say that word, believed. So many scientists are believed. The scientists also believing. Here we have to make it clear. The scientists who don't believe, only believe on the proofs, they are also believing on this theory, Big Bang theory. Okay. So according to that theory only will come. And so this universe is infinite, and in this infinite universe, We don't know where we are. So our Milky Way is uncountable in this vast universe. Of course, there are so many Milky Ways are taking birth, and so many are dying because of the black holes, because of the dark energy, which we are thinking most famously, majority of the theory given by the Einstein. He was exactly born on the equinox time. So now they are able to prove it to scientifically, they are able to prove it to some extent. But majority is only on the belief, just like the religions. So this is infinite universe, and our Milky Way is negligible. Even our Milky Way vanishes today. And today means again the time is existing. The time is existing because of the rotation around the sun. The time means if you are coming in the under time, you are following some loop. So if you are coming out of that loop, there is no time. So again, that's why the time is also a created thing. Actually, the time don't exist. Okay, if you think like that, so our Milky Way is negligible. Yes, we'll come to our Milky Way, and in that Milky Way we don't know where we are and in which Milky Way we are, and so of course our Milky Way, in that Milky Way we don't know where we are. Our star, where it is. There are so many stars bigger than our star, and there are so many stars smaller than our stars, and different types of stars are there. Our star is the sun. Our star is the sun. So we are calling it as the sun because it is also a star. So because of this truth told by the scientist, he was killed in the Europe. So our sun is also a star. Up to that, they are thinking that our sun is the center for this universe. He proposed that our sun is also a star. Okay, our sun is also, and also other thing is the Earth is the center for the universe. They thought, because that's why it is called. We are calling it as human-centered theories. So our sun is also a star like other stars, and the sun is not revolving around the Earth, and our Earth is revolving around the sun. So that is the fact which was proposed by the people, the scientists in the olden days, and they were killed for telling this thing. And Galileo was threatened to be killed, like that. So that is a different case. So our sun, as far as our majority of science, scientifically, now we have to talk. So the sun, we don't know where. Maybe it is somewhere not nearer to the center of the Milky Way, not away from the center of the Milky Way. So that's why probably we are thinking that is the reason for our existence of the Earth. So even if you think that our sun, so the biggest sun, as far we know, that biggest star is the Caris Majoris. Up to now we know that, which is the biggest star we have found. And there are stars which are revolving around the planets, not in this case. So here planets are revolving around the sun. There are cases where the sun is very weak and planets are the sun is revolving around the planets. That type of solar systems are also there. So our case is not like that. We are our is a good solar family with 9 planets. Okay, that is along with the sun, which are revolving around the sun. So here, So if you come to the sun, our sun is not a new star or a young star, and similarly it is not a old star. If it is a red star, that means the star has become old. So our sun is in the middle of its age. You can observe here, this is our solar system. The sun is there. The planets you can find: Jupiter, the largest planet, which we are taught the Jupiter is also revolving around the sun, which is actually not correct. So Jupiter is a heavy planet. So sun and Jupiter, it seems like that, but are revolving about another center, which is heavy center. The remaining planets are revolving around the sun. So actually we see our sun like that. But if you go out of our atmosphere, you cannot find that environment, because that is a vacuum. That is a space, because of the atmosphere around our earth. It's looking like that. So if you go to the sun is a very huge structure in our solar system. There is no big thing than sun in our solar system. Only the thing which is bigger thing in our solar system is the sun, the one and only sun. So it's having different layers, along with the rays, X-rays, gamma rays, ultraviolet rays, and photosphere, random walk radiation pattern, magnetic rope, coronal hole, corona. All these things we are having in the sun, and we will want to discuss in deep. So what is the mean distance from the earth, sun? What is the mean distance from the earth? That is 1,496 million kilometers. It is 1,496 million kilometers. And length of solar radius is 696. That is 6,96,000 kilometers. It is the radius. What is the mass? Is 1.98 into 10 power 30 kg. And volume is 1.412 into 10 power 27 meter cube. And density in core is 1,51,300 kg meter cube inverse. And mean density is 1,409 kg m to the power of minus 3. And pressure in the core is 2.334 into 10 power 11 bar. And surface of the photosphere is 0.001 bar. And surface temperature is 5,780 K. And if you come to the age, is 455 billion, 4.55 billion, and lifetime is about 5 billion years. And energy output is 3.9 into 10 power 23 kW. What is the luminosity? Is 3.854 into 10 power 26 J/S inverse. And the solar constant is 1367 watts per meter square. And the chemical composition. So many people think what it is made up of, what a star is made up of. It is simply a combination of two gases, that is hydrogen and helium, and only very negligible amount of other elements, that is 0.1% of other elements are there. So that is 92.1% hydrogen and 7.8% helium and 0.1% other elements. And the escape velocity is 618 kilometers per second. So if it comes to the Earth, you want to escape, you have to move with 11.15 kilometers per second. Yes, 12 kilometers per second only. Okay. So the period of serial rotation is 25.4 by 27.3 days. Okay, that is it. Time of rotation around galactic center, galaxy. We have discussed, no? It is also rotating around the sun, is also rotating. Our planets are rotating around the sun, and sun is rotating around the center of the galaxy. So that is 2.4 into 10 power 8 years. What is our next star? What is nearest star? Alpha Centauri. And what is our next galaxy to our galaxy? Which is nearer, next means nearest galaxy to our galaxy. That is Magellanic Cloud. We have given the name of that as the Magellanic Cloud. Okay, that's about the calculation, different calculations, data about sun. So it is having different layers, gamma layers, X rays, gamma rays, and layers. The spots which are visible are the black spots. So that's why it is, the spots will be changing. So the surface is not exactly fixed. It will be changing. So this is how actually the sun will look from the cameras of the stations. With naked eye, we cannot see. We cannot observe about the sun. See, all the knowledge we are getting with the observation. Scientist, anybody, an observation and coming to the conclusion and applying it. All this has happened about the knowledge. And what are the cores? Different stages. The sun. Everybody knows the core. Earth is also having core. So, what is the hottest place of the Earth? The core. The Earth's core. What is the hottest place of the sun? Sun's core. The core will be always with high temperature in any object, naturally. So it will be having a core which is giving actual heat and light. The basic heat and light. Yes, sun is the basic source of life on the Earth. Of course, there are so many suns, so many stars. And Earth is the place, up to now, we know where we are, the living beings are there. And after that core, that is radiative zone. And after that, convective zone. So these are the different zones. So in single statement, if you want to say what is the sun, so it is a star. You can say it is a one star. It is the nearest star. It is the sun, which is made up of heat and light. If you want to tell in the form of chemical term, hydrogen and helium. So this is the solar system. Mercury, Mars, Earth, Venus, Jupiter, Saturn, Neptune, Pluto. All these things we have been knowing right from our childhood. So it is the source of heat and light in our solar system. So what is the diameter of the sun? What is the diameter of the sun? So it is 8,64,938 miles. It is 8,64,938 miles, or 13,91,980 kilometers. 13,98,980 kilometers. So that is the diameter of the sun. So that much huge it is. Actually. So we have to tell in other terms. Always we have to compare. So how we can compare? One thing is, if you want to compare the ocean with, you will go for some big pond or like that. So what is the next thing which is bigger after the sun in our solar system? That is Jupiter. Or otherwise we are on the earth. So we can compare with the earth. So if you are comparing with Jupiter, so this is almost 10 times larger than the planet Jupiter. So we are telling that the Jupiter is the largest planet in our solar family. So for that largest planet also, it is 10 times bigger. So if it is 10 times bigger than the largest planet in our solar system, then what about our Earth? So it is 100 times bigger as the Earth. So it is 10 times larger than the Jupiter and 100 times bigger than the Earth. So what are the parts? So normally we learn by dividing into parts. So what are the parts? So that is photosphere. Similarly, the Earth is having layers: troposphere, ionosphere, like that. Similarly, like that. The sun is also having layers. So Earth is having core, which is in the molten stage. After that, rocky layer. After that, Earth. Above that, different spheres: stratosphere, ionosphere, troposphere. Above all these things, ozone layer. Like that. The sun, similar way, the sun is also having different layers. So that is photosphere, sunspot, and the core, and the corona, and the prominence, and the chromosphere. What are these things? Photosphere, sunspot, core, corona, prominence, and chromosphere. What are these? We will know it in a simplest form. Photosphere. It is the thing which is visible on the surface of the sun. Photosphere. It is yellow color. Sometimes we can see this yellow color from our Earth also with naked eye. So it is yellow color. Yes, where you can find solid, you cannot find solid because it is made up of gases. It is not a solid surface, but rather a layer of gases. And the temperature is about 5500 degrees centigrade. So it is the visible surface. Photosphere is the photo. Photo means light. Photo, it is the visible surface of the sun. Sunspots. So sometimes we will be finding sunspots if you observe with the camera, and even because of the electromagnetic and some cyclones, solar cyclones, it will be coming. Based on these things, they will show the sun's electromagnetic field. So much of electromagnetic field will be coming to the Earth's surface, so it will interrupt because of the explosion in the surface of the sun. So electromagnetic energy will be falling on the surface. Of course, the Earth's electromagnetic field will protect that our Earth from that effect, but it will be disturbing. So because of the disturbance, they will tell that your cell phones may not function properly for some time. Your TVs and radios may not properly. This will happen actually because of this explosions. So which is indirectly, we can see it as the sunspots. They will be calling it as the solar cyclone. Solar cyclone. They will be calling. Similarly, they will be calling different planets also. This type of things will be occurring, and because of different gases or different materials, different environments. So this is sunspots. So this will be varying because of the combination of variation of explosions on the sun. Core. So this is the center, and where we will be getting all this light and heat because of the fission, nuclear fission. So who is forcing this? Actually, it is a dust. Okay, it is a dust. So this dust has been forced such a way with that much of pressure to form a nuclear fission and form into gases. This is a fuel. So because of the dark energies in the space which are expected, we don't up to now we don't have any equipment to find that, to measure that, to find that, show that, like other things. But it's only our imagination. It's our imagination. Something must be there. Something must be there. So because of that force, they have come closer, and that much of pressure, they have started nuclear fusion, nuclear fusion, and we are getting so much of, which is similar. This is also nuclear energy, and like our nuclear materials. So here we'll be having fission, actually fission. So if you are able to control that fission properly, you will get energy. If you are unable to control that, it will become a nuclear bomb. Here we are having nuclear fusion. So we are having nuclear fusion. And so in that core, the temperature will be very high, that is 10 millions to 20 millions. 10 millions to 20 millions. Okay. So the corona actually, it will be surrounding the sun. Actually, we cannot see in the normal. If you want to see it in the, we can see it in during the eclipse times. You can see it during the total eclipse times. So it will be like a crown. It will be like a crown. We can see from the earth also during the eclipse times. And the prominence. So it is a cloud structure, cloud-like structure. You can observe here. So the small part. If you go closer, it will be like a cloud-like structure. So, but we are not saying it is the surface of the sun. So, cloud-like structure, large amount of gases, looks like a huge flame coming out of the sun. So sometimes if it is heavy, this is what here we are actually coming. We are actually coming to the point. Okay. That's we are calling it as cyclones in the sun. Cyclones in the sun. And that's why. So it is a cloud-like structure and large amount of gases. Looks like a huge flame coming out of the sun. And above all this thing, above the photosphere, so it is red. It is viewed as a red rim. Actually, we are saying the photosphere is the surface of the sun, but above that we will be having a red rim-like thing, which is called as the chromosphere. So above the photosphere, thick layer of boiling and spinning gases. The gases will spinning. You can imagine. And viewed as a red rim, and the temperature is 27,800 degrees centigrade. So this is for the sun. See, what is the mean distance is 1,496 million kilometers, and the length is 6,96,000 kilometers. Radius and the mass and the density in the core. And if you see that, so what is the star nearer to our star? So that is the Alpha Centauri. And what is the Milky Way? What is the galaxy nearer to our galaxy? So that is Magellanic Cloud. So this we have actually so many people don't know. So that is, so the sun is also rotating. The sun is also rotating to the around our center of the galaxy. That is 2.4 into 10 power 8 years. These are the details, and we'll see what are the. Okay, we'll be having different layers, gamma rays, alpha particles, and magnetic ropes, all these things. So basically, we are saying that into three zones, that is the core and radiative zone and convective zone. So if you come into zone, core, radiative zone and convective zone, and it is a star with light and heat. So the planets are revolving around the sun, and it is the basic source of all. So it is directly or indirectly life. It is a life for all the living beings, and it is the basic energy behind all the energies on this earth. So basically, so it is its diameter is 8,64,938 miles, or 13,91,980 kilometers. And similarly, it is 10 times bigger than the Jupiter and 100 times bigger than the Earth. And what are the parts? That is photosphere, the sunspot, the core, the corona, the prominence, and the chromosphere. So the photosphere is the outer surface of the sun, which will look like in the color of the yellow, and the sunspots is a dark patch on the surface of the sun, and the core, so it is the actual highest, it will be the highest temperature and light. So it is 10 millions to 20 million degrees. So you cannot imagine that much of heat. And so corona will normally we cannot find, but during the time of the eclipse, total eclipse, you can find this corona, which will be in the brown color, which will from the earth. It will be like a crown, bright light glowing. And prominence, it is coming out. It looks like something coming out of this surface of the sun, which is a cloud-like structure, and large amount of gases and huge flames are coming out. And the chromosphere, so it will look like a red rim, and with a temperature of 27,800 degrees centigrade. So these are the different layers of the sun, different zones of the sun. So the size of the sun, the diameter of the sun, and what are the particles it is actually made up of. That is helium, 92.1% hydrogen, and 7.8% helium, and only negligible amount of 0.1% of other elements. So it is basically made up of. So the nearest star is Alpha Centauri, and nearest galaxy is Magellanic Cloud, and the sun is also revolving around our center of our galaxy, that is with the speed of 2.4 in 10 power 8 years. So normally we will measure in the space with the years, light years, space with the light years. So that's about the physics of the sun. I hope you have enjoyed the subject, and thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.